Now in this lesson we look at an introduction to functions. Now a function is a relation between two variables, okay, and it's often x and y because they're generally the coordinates we're using. So let's consider x and y in this case, where for every value of the independent variable x there is only one value of the dependent variable y. So the only one value is very important, and we can see that by a vertical line test. Okay, so at the moment it probably doesn't make a great deal of sense, but let's just see a diagram, a few diagrams, and we'll see this vertical line test to see whether something's a function or not. Let's consider the first one. Looks a little bit like a cubic curve. Now if we did a vertical line, okay, series of vertical lines, it just hits there once, hits that spot once, hits the graph there once. Okay, it's only hitting the graph once at any one time, so we say yes, it is a function. Conversely, let's have a look at this circle. If we do the vertical line test, well, it cuts the graph twice. Okay, it has two y values there for that x value. So no, it's not a function in this case. This one here, a straight line. Do the vertical line test. Okay, just cutting it once. That's just cutting it once. So again, yes, this one is a function. And this one here, a parabola on its side. If we did the vertical line, you can see again for that value of x, it's got a y value up there, a y value down there. So no, that's not a function. Now let's look at some notation for functions. Now we're given that f of x, that's how you say it, f of x, so it's a function in terms of x, is equal to 2x cubed minus x squared plus 4. We're asked to find two things, f of 2 and f of negative 3. Now f of 2 firstly. So let's just write our original function down. Now f of 2 simply means to replace the x with a value of 2. That's all it means. So in the expression there, 2x cubed minus x squared plus 4, those x's highlighted, we're just going to replace with 2. So there we have it. 2 times 2 cubed minus 2 squared plus 4, and we calculate that, works out to be 16. So it's a pretty simple concept. The next one, f of minus 3. So let's just write down our original function again. Now f of minus 3 will equal, okay, so again the x has been replaced with minus 3. So wherever we see x replaced with minus 3, this is what we get. And it's just a matter of being careful entering those things on the calculator. Really, we get minus 59. Our next one, you are given that f of x is equal to x squared minus 4x. We're asked in part A to find the values of x for which f of x is equal to 0, and in part B find the values of x for which f of x is less than 5. Okay, let's do part A firstly. There's our original function, and we want to see when does it equal 0. Okay, so we set that equal to 0. If we're setting that equal 0, we get that x squared minus 4x equals 0. Okay, so we're saying when does f of x equal 0? When x squared minus 4x is 0. So we've got an equation there, a quadratic. So we try to factorize. So we take the x out. So x outside of x minus 4 equals 0. And two little equations to solve. X equals 0, there you have it. Or the other one, x minus 4 is 0, so therefore x would equal 4. Part B, find the values of x for which f of x is less than 5. So let's just write down our function again. And we require when f of x is less than 5. So in other words, when is that function? Less than 5. So when's x squared minus 4x less than 5? Now, what we need to do is get everything to one side. So let x squared minus 4x, let's write that down. The 5, we'll bring it over, it'll become minus 5 on the other side. And that'll be less than 0 because we've got everything to one side. Now it's a quadratic inequation, okay? So what we need, you still need to factorize that. So two brackets, end up getting x plus 1, x minus 5, and that's less than 0. And we need a number line because it's an inequality. So here we go. When x plus 1, when that equals 0, we're interested in when x equals minus 1, so that's 1 point. And when x minus 5 is 0, well, we're interested where x equals 5. So if you recall what to do now, we're going to substitute and check points. So if we substitute a number on this side of minus 1, let's say when x equals minus 10, if we put it into that equation, or that inequation I should say, and see whether it's true or false. Well, if we put x equals minus 10 in, you'll come up with a false statement, okay? Now what about a number between minus 1 and 5? Well, the easiest number of course is 0. So let's just substitute x equals 0 there. We end up getting 0 is less than 5, and that's true. Pick a number on this side, let's say 10. We substitute 10 in, we get 10 squared, that's 100, minus 4 tens are 40. 100 minus 40, that's 60. So is 60 less than 5? Well, no, it's not. So it's false on that side as well. So we're interested in x values between minus 1 and 5, and that's exactly how we write it. We say minus 1 is less than x, which in turn is less than 5. Excellent. Our third and final example in this lesson, g of x. Alright, so it's not always f, okay, it could be a different letter. G of x is defined as, alright, and this is a little bit different because we're going to have three rules we're looking at for various values of x. We've got it equals 3x minus 4 for x greater than or equal to 2. It equals 2x plus 5, alright, if x is between minus 1 and 2. And finally, the rule is that it equals 6 minus x if x is less than minus 1. So we've got three rules to contend with depending on what x is. So we're asked to find a, g of 5, b, g of 0, g of minus 3, and finally g of 2 plus g of minus 1. Now let's do part A firstly, g of 5. So look at the x has been replaced with 5. So of those you can see that we're choosing an x value which is certainly greater than 2. So we're going to use the first rule. Okay, I'll call that the first rule, the one underneath the second, and the bottom one the third. So we're going to use that first rule there, and we're going to replace the x with 5. So we do that, we get 3 times 5 minus 4, works out to be 11. The next one, g of 0. So let's write that down. Now the x has been replaced with a 0. So our x value is 0, so it would fit within there, wouldn't it? Minus 1 less than or equal to x, less than or equal to 2. Well, 0 fits somewhere in between there. So as a result, we're going to be using this second rule. So using that second rule for x is 0, we substitute, we get 2 times 0 plus 5, and that works out to be 5. The next one, g of minus 3. Well, g of minus 3, let's write that down. The x has been replaced with minus 3. So again, which rule do we choose? Well, look, if x is minus 3, well, certainly it's less than minus 1. So as a result, we're going to be using this third rule. So using this rule, when x is minus 3, we get 6 minus 3, and that works out to be 9. Okay, lastly, g of 2 plus g of minus 1. Let's write that down. G of 2 firstly, though. Now, x has been replaced with 2, so which rule? Well, we're going to use this one because it says x is greater than or equal to 2. Alright, certainly x equals 2, so that's the rule. Using the first rule there, when x is 2, we substitute, and we get 3 times 2 minus 4 works out to be 2. Now, g of minus 1 then. Let's substitute. The x value is minus 1. Need to work out which rule we're going to use. Alright, before I tell you, have a bit of a think. Okay, first, second, or third? Well, x is minus 1 will fit in that little range there. Okay, minus 1 is less than or equal to x, so it equals x there. So that's why we're going to use this second rule. So using that second rule, when x equals minus 1, we get this, 2 times minus 1 plus 5, and that works out to be 3. So therefore, we can write that g of 2 plus g of minus 1, simply add up the two numbers, 2 and 3, and we get 5 as our final answer.